Hey guys, so today we're going to be talking about reciprocal trig graphs. So we're going to be looking at secant and cosecant and cotangent. And for this, to start with, we're going to graph secant. So I've got my set of x and y axes set up and I've got some labels going on. I've also got a table here so we can see what happens to the points. In order to fill out this table, we're going to need a little mini unit circle. So I'm going to make a quick guy over here. And notice in this table that I just threw down the pi over 4 radians, so I'm counting 1 pi over 4, 2, 3, 4, 5, 6 pi over 4, 7 pi over 4, 8 pi over 4. So that's all I'm going to fill out on my unit circle. Let's see, on the axes, those are the easy ones first. So this is over 1 up 0, this is over 0 up 1, back 1 up 0, and let's see, this is over 0 down 1. And let's see, I've gone back root 2 over 2, up root 2 over 2, back root 2 over 2, down root 2 over 2, forward root 2 over 2, and down root 2 over 2. There we go. Alright, so at 0, I'm looking at cosine, and the cosine of 0 is 1. Since secant is equal to 1 over cosine, and then I know I can make secant be 1 over 1, which is 1. At pi over 4, cosine is root 2 over 2. So here I'm 1 over root 2 over 2, which if you were to spend a little time rationalizing, let's see, I'm going to take the reciprocal of that, so it's 2 over root 2. I rationalize, I get 2 root 2 over 2. I'm running out of space here. I cancel the 2's and you end up with just root 2. Let's see, pi over 2 is up here, cosine is 0. 1 over 0 is undefined. At 3 pi over 4, I'm at negative root 2 over 2. Since I've already done the math for rationalizing, I'm going to get the same answer as at pi over 4. It's just going to be negative. At pi, I have a negative 1, so 1 over negative 1 is negative 1. You're going to start seeing repeating vectors. 5 pi over 4 is negative root 2 over 2 for cosine. So this is negative root 2 again for secant. 3 pi over 2, cosine is 0. So we have 1 over 0 for secant, which again is undefined. 7 pi over 4, we're back at positive root 2 over 2 for cosine. So we're at a positive root 2 for secant. And at 2 pi, we're back to 1. So we're 1 over 1, and secant of 2 pi is 1. All right, now, root 2 is about 1 point something. I don't remember, is it 1.4 or 1.7? Well, it's, where's my darn calculator? I should remember this, but I don't. So, just to make sure that I don't mess up on video, I'm going to double check it on my calculator. The square root of 2 is about 1.414. There we go. And I'm just using that approximation decimal so when I come over here to graph, it's easier to look at, or easier to graph. So now I'm going to graph these points. At 0, I'm going to go up 1 and put a point. At pi over 4, I'm going to go up root 2, which is about 1.41. So I'm going to go up 1 and not quite a half. At pi over 2, I'm at undefined, so that means pi over 2 is going to be an asymptote for me, a vertical asymptote. At 3 pi over 4, I'm at negative root 2, so that's going to be negative 1 and not quite a half. At pi, oh let's see, shoot. Yep, at pi, we're at negative 1. At 5 pi over 4, we're at negative root 2 again. At root 3 over 2, I have another asymptote. And let's see, at 7 pi over 4, I'm at positive root 2. And at 2 pi, I'm at 1. So just by looking at the dots here, I can connect these guys. That looks like a curve there. But then it might be a little unclear, and I can connect these guys too, where your graph would go from here. Your graph usually approaches its vertical asymptotes, and so that would mean from here, it would continue in the same pattern as going down, and it would get closer and closer to the asymptote. Same thing on both sides. And here it's going to get closer and closer to the asymptote. So we've got some direction on either side there. Now this is one sort of cycle of the secant curve. If I were curious though to look at more cycles of the secant curve, I might want to graph it on my calculator because obviously it takes a little less work too, and I can look at a bunch of cycles at once. So secant, on your calculator there isn't really a but for secant, and it certainly is not, let me stress, cosine inverse. This cosine to the -1 is not the same thing as secant. It's not 1 over cosine. This is just an inverse notation, like f to the -1 power. So in order to graph secant, we're going to have to actually go ahead and plug in 1 over cosine into our calculator. So you would do 1 divided by cosine of x to get your secant curve. It's unfortunate there's not a button there for you. And then you want to make sure your mode is in radians, which mine is. And then we can take a look at the graph. I'm going to set my window just in case it's funky. So I'm going to go negative, let's see, 4 pi to 4 pi. I'm sort of stretching out my x-axis a little bit to get a bigger view of what the secant curve looks like. My scale, I'll go ahead and do by pi over 4. So my tick marks match up the same as my graph. And the y-min, well, sure, -10 to 10, that looks fine. So notice on this secant curve, you're getting this repeated, they look like parabolas, they are not actually parabolas, but you are getting this sort of repeated U shape here for the secant curve. Okay. So if I were to keep graphing this, what I would see is that this guy would curve back up and make his, and this guy over here would curve back up and make his U also. Now, you're probably wondering the fast, quick, and dirty way to graph secant without having to make a big table, without having to use your calculator. And the way to do it is actually to draw cosine in first. So cosine starts at 1, it goes down, hits 0 at pi over 2, goes down to its low point, back up to 0, right? And so wherever the cosine curve hits 0, that's where your asymptotes are going to be. And wherever cosine is at its highs or its lows, those are going to be the bottoms of your U's or the top of your U's. Okay? So I'm going to use that method of graphing actually to graph cosecant because I'm sure that you don't want to listen to me filling out a table again. So if I'm going to graph cosecant, I know that cosecant is the reciprocal of sine. Okay? So I'm going to start by graphing a sine curve. Now let's see, sine starts at 0, it's line. And then it goes up to its highest point at pi over 2, back down to 0 at pi, down to its lowest point at -1 at 3 pi over 2, and then back up to the midline at 2 pi. So there's the basic sort of single cycle of the sine curve that we're used to seeing. And now if I want to graph cosecant, what I'm going to do is put asymptotes at the, because 1 over 0 is undefined. And there's actually also an asymptote here, which is kind of hard to see on the sine curve. I'm going to like try and make it look dotted by just making that a little bit darker. And then the highs and the lows are the tops and the bottoms of the U's. So at this high, it's going to reflect away from the x-axis. So the U shape will go like that. And here, it's going to reflect away from the x-axis again, and that U shape will look like that. So there's your cosecant curve, which looks a lot like your secant curve, just shifted over a little bit. Just like sine looks a lot like your cosine, just shifted over a little bit. Last but not least is cotangent. It is a little bit tricky, it's a little funky, because our silly tangent curve is centered at 0, 0, right? We're used to looking at our tangent curve centered at 0, at pi over 4 it's at 1, at negative pi over 4 it's at -1. So here's my silly tangent curve. And my first asymptote is at pi over 2. And then my next asymptote, since the period of a tangent curve is pi, is over pi. So here would be my next asymptote, right? And then, let's see, I would have another cycle of my tangent curve like this. If I were to repeat this cycle. And if I were to repeat it again, here would be my tangent curve. Well, this is unfortunate. There's a lot going on here, and it's not quite as U-shaped where you can just reflect the graph away. It's a little bit trickier. So, unfortunately, what I would do if I were you guys is probably not use tangent to graph cotangent, although you can use some key points. Because we're doing 1 over, cotangent is 1 over tangent. The 1s and the 0s are going to be especially helpful. For instance, if tangent is 1, 1 divided by 1 is 1. So right here, at this point, 1 divided by 1 is 1. So that point stays the same. And anywhere there's an asymptote is going to be a 0 on the cotangent graph, the same way as above our asymptotes and zeros coincided. And then anything that's a negative 1, well, 1 divided by negative 1 is also negative 1, so that stays. And then anything that's a 0 is going to turn into an asymptote. Okay. So if I wanted to graph one cycle of my cotangent curve, it's going to go from 0 to pi. There's one cycle of my tangent curve, with the x-axis, by the way, being the other side of the asymptote. Okay. So here's one cycle of my cotangent curve. This would be one that I would say it's probably easier to just memorize what one cycle of the cotangent curve looks like, that its period is pi and it hits 0 and it has sort of a negative slope. I think this guy is easier to memorize than it is to get from the tangent curve, but it's up to you on how you want to do that. In any case, the period of cotangent, just like the period of tangent, is pi, whereas for the other guys, the period of cosecant is 2 pi, is 2 pi, just like their reciprocal functions. They get their periods from their reciprocal functions. All right, that's it for notes tonight. If you have any questions, maybe leave some comments. I'm wondering if I should maybe do more with these graphs. So if there's more that you would like to see, maybe leave it in the comment section on the YouTube video, and that way I can know if I need to add something for 5.4c. Thanks, guys. Have a good night.